Welcome back, our dear learners. We are discussing trigonometry, pure mathematics, and we are talking about half angles. We are talking about half angles. Now, from sine of A, this is 2 sine A over 2 cos A over 2. Also, we can talk of cos of A. Cos of A as a direct deduction can be cos of A can be cos squared A minus sine squared A over 2. These are direct deductions from the double angles. I want to recall that if you have cos 2A, we discovered that this is cos squared A minus sine squared A. So if this is A, by all means you can see there is some division that has taken place to remain with single angles here. So if you have a single angle, if you divide, it becomes half of that angle. So back here, cos of A can also be 2 cos squared A over 2 minus 1. And it can also be 1 minus 2 sine squared of A. It can also be 1 minus 2 sine squared of A. Now, these half angles are very applicable, especially when we are proving identities or when we are solving tricky problems. But we are going to apply them much more in the T formula. The T what? T formula. But first note something here. Note that cos squared A over 2 plus sine squared A over 2 is equal to 1. This is a trig identity we proved. We proved it using single angles. So if they are also half angles, the square of the cosine of those half angles plus the square of the sine of those half angles will always give you a 1. Will always give you 1. Now, as I have said that these half angles are applicable, especially when dealing with the T formulas, let's talk about the T formula. Let's talk about the T formula. Let's talk about the T formula. Now, from sine 2 theta, sine 2 theta is 2 sine theta cos theta. Okay? It is 2 sine theta cos theta. So if it is 2 sine theta cos theta, we've just proved that from double angles. I can divide by 1. Now if I divide by 1 on the right hand side, I will have sine 2 theta as 2 sine theta cos theta over 1. But in trigonometry, that 1 is not just a 1. The 1 is equal to cos squared theta plus sine squared theta. Therefore, sine 2 theta is equal to 2 sine theta cos theta over cos squared theta plus sine squared theta. Now at this level, you divide by cos squared theta. If you divide by cos squared theta, we have sine 2 theta is equal to 2 sine theta cos theta over cos squared theta, then over cos squared theta over cos squared theta plus sine squared theta over cos squared theta together. Now, I want to focus here because this one challenges you. This one can be 2 sine theta over cos theta, then times cos theta over cos theta. This cos squared theta, I said, can be thought of as cos theta everything squared. That's why I'm having this. Now you can see that this one goes away with that. Sine over cos is a tan. Therefore, up there we have 2 tan theta over. Now, cos squared over sine squared is 1 plus sine over cos is a tan theta. That one is the value of sine 2 theta. Now, if I let t to be tan theta, if I let t to be tan theta, that means sine 2 theta is 2t over 1 plus t squared. That's where the word t formula comes from. The t comes from nowhere, but if you substitute the tan theta with the t, that's where this one comes from. Let's look at that of the cosine. Let's look at that of the cosine. Also, cos 2 theta from double angles, we proved that this one is cos squared theta minus sine squared theta. Now if I divide by 1, I'll have cos 2 theta is equal to cos squared theta minus sine squared theta over 1. Okay? But we said that this one in trigonometry stands for some rates, and the rates are none other than cos squared theta plus sine squared theta. So cos 2 theta is cos squared theta minus sine squared theta over cos squared theta plus sine squared theta. Okay? So let's divide through. Let's divide through by cos squared theta on the right hand side. If you divide through by cos squared theta, you have cos 2 theta is cos squared theta over cos squared theta minus sine squared theta over cos squared theta, then all over cos squared theta over cos squared theta minus sine squared theta over cos, no, this is a plus sine squared theta over cos squared theta. Now this one generates a 1. We have a 1 minus tan squared theta over 1 plus tan squared theta. That is cos 2 theta. That is cos 2 theta. So if I let tan theta to be t, if I let tan theta to be t, that means my cos 2 theta is going to be 1 minus, but this is tan squared theta. So that means if I have a tan theta, this one, and it is equal to t, this one will become t squared over 1 plus t squared. Okay? And directly we can prove that tan 2 theta, we are talking tan 2 theta. Tan 2 theta is sine 2 theta over cos 2 what? Cos 2 theta. Sine 2 theta, we have looked at it. This is tan 2 theta is equal to sine 2 theta. We've discovered it is 2t over 1 plus t squared. Okay? We are dividing this one by this one. We have discovered it is 1 minus t squared over 1 plus t squared. Okay? So, this is 2t over 1 plus t squared times 1 plus t squared over 1 minus t squared. Automatically, those two will cancel out and you remain with 2t over 1 minus t squared as the value of tan 2 theta. Now, I can summarize all of them. I can do what? I can summarize all of them, and say that therefore sine 2 theta is 2t over 1 plus t squared, cos 2 theta, this one is 1 minus t squared over 1 plus t squared, tan 2 theta, this one is 2t over 1 minus t squared. For t is equal to tan what? Tan theta. Conversely, we can have sine theta is equal to 2t over 1 plus t squared. Cos theta is 1 minus t squared over 1 plus t squared. And tan theta, this one is 2t over 1 minus t squared. For t is equal to what? For t is equal to tan theta over 2. Are you spotting the difference? These are double angles. The t is halved to get the theta. The corresponding angle for that case is halved. These are singles. The corresponding angle will be theta over 2. It will be theta over 2. These formulas are very much useful, especially when we are solving trig problems. They are very useful when solving trig problems. And those trig problems are like the ones I'm going to give you here. Let me look at one of them. I'll give you the rest in your prep. We have Ig. Solve the following. Solve the following for 0 degrees less or equal to theta less or equal to 360 degrees. Number part A, we have we have 2 cos theta plus 3 sin theta minus 2 is equal to 0. We also have 3 cos theta plus, no, it is a minus 4 sin theta plus 1 is equal to 0. Now, we have looked at tricky problems before that require us to solve to generate angles. Previously, we are lucky enough, we could find maybe there is an identity we are going to use, but here, both angles are the same. These are single angles for the two trig ratios, cos and sine, and secondly, none of those ratios is squared. So the best deal to use, or the best deal to go for, is we can apply the T formula. So solution part A, we have 2 cos theta plus 3 sin theta minus 2 is equal to 0. And from cos theta, which is 1 minus t squared over 1 plus t squared, and sin theta, which is 2t over 1 plus t squared, for t is equal to tan theta over 2. If I substitute, because I'm interested in uniformity to calculate, okay, we have 2 into 1 minus t squared over 1 plus t squared, that is the representative of cos, then plus 3 into 2t over 1 plus t squared, this one minus 2, that one is equal to 0. Okay? So, we have 2 into 1 minus t squared plus 3 into 2t minus 2 into 1 plus t squared all over 1 plus t squared. I've placed everything under the same LCM. You have a 0 there. If you cross multiply, I can place a 1 here. This one goes with a 0. These ones go with the 1. So if you cross multiply, you have a 2 into 1 minus t squared plus 3 into 2t minus 2 into 1 plus t squared. Everything is equal to 0. Let's open brackets. Okay? Let's open brackets. This is a 2 minus 2t squared. Here you have a plus 3. No, it is a plus 6. Because we have a 3 times 2 giving a 6t. Then minus, we have a 2. It is a negative. So the 2 multiplies, you have a 2. Then the 2 multiplies there. Because of this sign here, we'll have a minus 2t squared is equal to what? That one is equal to 0. So that one is equal to 0. We have the 2 cancelling with the 2. Is that so? Yes, it is. Then we have negative. No, it is this and that giving you negative 40 squared. Then this one is a plus 60t. Everything is equal to what? Everything is equal to 0. The common factor here, we have a 6. So we have a t. It is not a t. You people try to follow up. It is not a t. It is negative 2t. So if it is negative 2t, I'll remain with a 2t here. Then here, I'll remain with a minus. It will be a minus 3 is equal to 0. So either negative 2t is equal to 0 or 2t minus 3 is equal to 0. We shall pick it up from there next time. We shall pick it up from there next time.